A limit describes what value a function is approaching as x gets close to a certain number. We write it like this. The limit as x approaches a of f of x is equal to L. As the x values get closer and closer to a, the output values, or the y values, get closer and closer to L. A limit is about the trend of the y values around x equals a, not necessarily the y value we get by plugging a into the function. Let's start with a simple example. Suppose f of x is equal to x plus 2, and we want to find the limit as x approaches 3. Let's first let x approach 3 from the left by picking values that get closer and closer to our value 3. If x equals 2.9, then f of x equals 4.9. If x equals 2.99, then f of x equals 4.99. If x equals 2.999, then f of x equals 4.999. It seems like as we're approaching 3 from the left side, our y values are getting closer and closer to 5. Now, let's let x approach 3 from the right by picking values that get closer and closer to 3 but coming from above. If x equals 3.1, then f of x equals 5.1. If x equals 3.01, then f of x equals 5.01. If x equals 3.001, then f of x equals 5.001. So approaching x equals 3 from the right side, it also looks like our y values are trending towards 5. So what do you notice? From the left and the right side of x equals 3, our y values are getting closer and closer to 5. So we say the limit as x approaches 3 of x plus 2 is equal to 5. Now, in this particular example, we could also plug 3 into our function and just get 5. But limits are not always that simple. Let's look at a graph where something different happens. Imagine a graph that gets closer and closer to the point 2, 4, but at x equals 2 there is a hole. Then there is a filled-in point at 2, 1. What is the actual function value at x equals 2? The filled-in point tells us that f of 2 is equal to 1. Our function is defined to be 1 when x is 2. But what is the limit as x approaches 2 of this graph? For that, we look at what the graph is doing near x equals 2. From the left side, the y values are getting closer and closer to 4. From the right side, the y values are also getting closer and closer to 4. Since both sides approach the same value, the limit exists, and the limit is 4. So here, our function value at x equals 2 is 1, f of 2 is equal to 1, but the limit as x approaches 2 of f of x is equal to 4. The function tells us what happens exactly at x equals 2. The limit tells us what the graph is approaching near x equals 2. So the limit can still exist even if the function does something different at that exact point, or it is not defined there at all. Now, let's look at a case where the limit does not exist. Suppose we have some function f of x that as x approaches 3 from the left, the graph gets closer to y equals 2. But for that same function, as x approaches 3 from the right, the graph gets closer and closer to y equals 5. So from the left of 3, our y value approaches 2, and from the right of 3, our y value approaches 5. Since those do not match our left and our right side limits, our overall limit does not exist. In order for the limit to exist, the left-hand limit and the right-hand limit must be equal. Basically, a limit describes the value a function approaches as x approaches a specific number. If the graph approaches the same y value from the left and the right side, the limit exists. If the graph approaches different values from the left and the right side, the limit does not exist. If you find my videos helpful, the best way to support them is to share them with someone else, or support the channel through YouTube memberships. I'm Joe, and thanks for spending some time with me.